All right. The last video we worked with square roots. Now we're going to use those square roots to help us solve some quadratic equations. I want you to recall the standard form of a quadratic equation. What does it look like? It looks like ax squared plus bx plus c equals 0. And the important thing is that a does not equal 0, and a is also the leading coefficient. If you look here, a is the coefficient that is first as you read it. That's the second that's the second coefficient, and that would be the third coefficient. Something that's a little new. Let's suppose that b is 0. When b is 0, then I can actually work out my standard form. Ax squared plus 0 plus c equals 0. Remember, b is 0. I plugged it in. And now I have ax squared plus c equals 0. I use inverse operations to get the c over here. I have a negative c now. So now I have ax squared equals negative c. Why did I do this? Because we're going to use isolating x squared and finding the square root of it. This is going to allow us to, I'm just going to have the x squared equals c, and we'll figure out how to find the square root after that. So, what does it look like? Solve the equation. First of all, another little quick note. If possible, write your answers as integers. Remember, integers are using the perfect squares. If it's like the square root of 16, my integer, the answer to the square root would be 4. 4 is an integer because it's a terminating decimal. The nice stuff to work with. Otherwise, we'll just leave the radical sign with our answer, and I'll show you what we're talking about. In the first example here, x squared equals 4. You might notice that, there's our x squared equals, basically it really would be a over c, but x squared equals 4. How do I solve that? Well, remember, in order to do that, we can put the radical sign over the 4. We're going to have two square roots, and x would be plus or minus the square root of 4. X equals plus or minus 2. So 2 and negative 2 is our answer. In this situation, n squared equals 5. I would write this out, n equals positive or negative, square root of 5, and I'm thinking, oh, that's not a perfect square. That's going to be approximately something. So we're going to leave the radical sign in there, and so n ends up being a positive square root of 5 and a negative square root of 5. We'll just leave our answer just like that. Another example here. What happens when it's 0? Remember, 0 times 0 is 0. So in this case, x is just 0, and we have one solution. Here's an another interesting special case that you're going to see from time to time. Y squared equals negative 1. So what happens when the answer is a negative 1 over here? Our answer, this is when it's undefined. There's no real solution. No real solution. Why is that? Because I can't think of a number I can put in here, multiply it by itself. I can't think of a factor times itself that's going to give me a negative. Because if you remember our rules for multiplying positives and negatives, it has to be the same number. So a positive times a positive is a positive. Doesn't work. A negative times a negative, that's positive. Again, not going to work. So basically the question mark is, what times itself gives me a negative 1? Nothing. 0. There's not even 0. There's no answer to that. So it's undefined and no real solution. I want you to be prepared for that. All right, so let's solve some here. 3x squared minus 48 equals 0. Remember, we can just draw the wall, and we attack the constants first in our equation through inverse operations. So I added 48 to both sides. My next level was 3x squared equals 48. divide by the coefficient so I can get x squared all by itself. I want to isolate it. And when I do that, I isolate it and I get x squared equals 16. Excellent. I know how to figure that out. I just need to find the square root of 16. So come on up here. X equals positive and minus square root of 16. Everybody knows 4 times 4 gives me 16. So x will equal plus or minus 4. I have two solutions in here, 4 and negative 4. Let's do another example. 27 minus 3y squared equals 0. So I kind of rearrange the order a little bit, and no problem. This is how we attack it. Same thing, I go after the constants. Inverse operation. So I'm going to subtract 27 from both sides. Now I have negative 3y squared minus 27. Now I just divide by the coefficient of negative 3, which is negative 3 on both sides. And now I have y squared plus equals a positive 9. Take this on up here, y squared equals 9. Same thing, y equals plus or minus the square root of 9, right? Well, I wanted to show you something really quick. Why do I get to just throw the square root symbol in there and it works? Remember, whatever we do to one side, we always do to the other side. So, really what I'm doing is, I am taking the square root of y squared, and if I take the square root of y squared, I have to take the square root of 9 because I have to stay balanced in my equation. Remember, the square root of anything that's squared inside here comes out as itself. So y is the correct answer. And that's where I got y previously, or x previously. Plus or minus, we all know what times itself is 9? 3. 3 times 3. 3 is the factor that will give us 9 when we multiply it times itself. So this particular one still two solutions, 3 and negative 3. The only thing I introduced in this problem is I wanted you to see a little more math on what was acceptable while I was able to do that. I took the square root of this side, which means I have to take the square root of that side to get my answer. We'll do another one. All right, example 5. 5t squared plus 10 equals 135. Again, inverse operations right away. I look for the constant and I subtract 10 from both sides. Now I have 5t squared equals 125. I divide by the coefficient of t squared, so that's 5 on both sides. And now I have t squared equals 25. I'm just going to keep going. I kind of fit all this one on one side here. Remember, now I'm going to take this, I need to get rid of that squared exponent right there. In order to do that, all I need to do is just take the square root. So I take the square root of this side, which means I need to take the square root of this side. Remember, we're going to have two answers, so it's a positive, negative square root of 25. And what happens here is the square root and the square symbol, they just cancel out, giving me t. That's what I want. We isolated t, and we've got plus or minus 5. Two solutions, positive 5 or negative 5 will work in here. One thing that I didn't show you, but we'll show in class is we're going to test them. Okay, last example right here. 3x squared minus 20 equals negative 2. I want you to see what happens with this one, compared to what we've been doing. As far as the answer goes, watch this. First of all, go after the constants. Same old thing. Positive 20, I get 3x squared equals 18. Take the coefficient of x squared, which is a positive 3, and use inverse operations, and so just divide it. We divide it on both sides. Now I have x squared equals 6. I'm going to go ahead and take the square root of both sides. Take the square root of here, square root of here. Make sure you include your little positive negative in front of it. This one, no problem. Square root, the square root sign and the exponent of square cancel each other out. Fantastic. I like that. This over here, Oh man, what factor times itself gives me 6? That's just a rectangle. It's not even a perfect square. So this time we're going to leave the radical sign with the answer. We're just going to leave it there. So x will equal the positive square root of 6 and the negative square root of 6. Notice 6 is not a perfect square, so just leave the radical sign in the answer. It's okay for now. When we get a little bit farther along, we may solve some more of that, but for now, you'll leave the radical sign in there if you don't have this nice perfect square.